On this video, I'm going to go through some examples of symbolization in predicate logic. And these are drawn from a homework assignment that I'm going to be posting after I do this video. They're taken from the book, from chapter 5, and they involve one-place predicates. One-place predicates, as you can see in the statement key here, the informal interpretation, have predicate symbols, like the letter C here, and next to the letter C there is just one place for an individual symbol. And when we give the statement key, we use the letter X or any other variable to indicate that that's a predicate symbol. So X is cute, X sleeps all day, X has a pleasant disposition, X prowls at night, X is smart, and then we have 5 cats: Annie, Buffer, Fluffer, Masha, and Ratso, which are the names of the cats that my cat and my co-author's cat from many years ago. The domain is cats. So what we're talking about is cats. We say the domain is what the variables range over. So anything that X is going to pick out, anything that these names pick out, is something in the domain, and it's a cat. So let's look at number 2. And I've highlighted these for myself just so I know which ones I want to go over with you. So Buffer is cute, but Fluffer is smart. So Buffer is B. So Buffer is cute is C, but Fluffer is F, is smart. That's kind of the Loglish version. Now, of course, you know that but just means and. So this is just going to be the ampersand between the two parts. And the way you say B has the property C is just like it is in the statement key. You put the individual symbol right next to the predicate symbol. So to say Buffer is cute, you just write CB. Cuteness applies to Buffer. And to say smart applies to Fluffer, you write SF. Buffer is cute, and, which is the same thing as but, Fluffer is smart. CB and SF. Lowercase letter represents one of these animals. Excuse me. The predicate symbol is the capital letter representing the property that the individual thing has. Let's go on to another one. So this one, let's see, 1, 2, 3, 4, and 5 do not involve any quantifiers. You just have to figure out, what the subject and predicate is of each component and what the connective is. But here means and. In this first one, Buffer is cute, there's no connective. It's just a predicate expression. Here we have an and for number 5. Only if is going to be a conditional. And when we get to number 8, we have a quantifier, the word sum. So sum means, excuse me, sum means there exists at least one. So when you say some cats are not cute, means there exists at least one cat that is not cute. Now here, this statement is an I-type statement. It's a particular affirmative. And ordinarily it has the form, pardon me, it's, I beg your pardon, it's an O-type. Some cats are not cute. It's an O-type statement. Particular negative, sorry about that. O-type statement, particular negative. Ordinarily this has the form of some, and let me use this, these curly letters here. Grab that. Some A. Then we go back to Times Roman again here. It should look like some A are not B. right? Some A are not B, right? Some cats are not cute, some A are not B. And if you recall from the text and from the earlier video, ordinarily you would symbolize that like this. You would write, there exists an X such that AX and not BX. So I didn't pick the curly font for the A and the B, but you get the idea. The O-type statement, the particular negative, is symbolized as there exists an X such that AX and not BX. And you'd think you should do that here. Some cats are not cute. The problem is, there are two problems. First of all, there's no predicate for cats. There's no predicate that says is a cat. Something that's an X is not cute. And the second thing is the domain is already cats. The domain is cats. The domain is cats. So when you start out by writing, for this one here, when you start out by writing, there exists an X such that, because the domain is cats, you're saying there exists a cat. There's at least one cat such that. When you the universal and the existential quantifier, when you say for all X, or there is an X, you're not talking about X's, you're talking about the things in the domain. So for every cat in the domain would be with the universal quantifier. There exists at least one cat in the domain, which would be the existential quantifier. So this here, this expression, there is an X such that, already says some cats. Some cats. You're already talking about some cats. There exists an X that is not cute, not CX. There exists a cat that is not cute. Okay? Let's move on to the next one. All cats prowl at night. And again, you would have thought that, and I won't bother with the curly font, this has the A form, universal affirmative, which is all A are B, right? Which ordinarily would be symbolized if you look at the PowerPoint video or the the text, AX arrow BX. It would look like that. For all X, if AX, then BX. But here, again, the domain is cats. And there's no predicate that says is a cat. You can't say all cats are, in the sense that there's a predicate for being a cat. The domain already is cats. So as soon as you write this part right here, the for all X, because you're talking about cats, because the domain is cats, for all X already says all cats. You're already saying all cats. What do? They prowl at night. PX. For all cats, for all X, P applies to X. Because if you look up at the domain, the interpretation, PX means X prowls at night, whatever X is. All cats prowl at night. Let's see, I have 4 more that I want to show you here. So, all cats with pleasant dispositions are cute. So, all cats with pleasant dispositions are cute. If we changed things, if we had changed things, if we said the domain is, if we changed the domain to everything, right? Suppose we did that. And suppose we introduced a new predicate, KX, meaning X is a cat. Suppose we did that. I didn't use K already, did I? No. Then this would be symbolized as, so for all X, if X is a cat and X has a pleasant disposition, what is pleasant? LX, I think. Let's make sure I've got that right. LX, so up at LX means X has a pleasant disposition. So for all X, if X is a cat with a pleasant disposition, then X is cute. All cats with a pleasant disposition are cute. Because then it has that A form. Then it's all K and L's are C's, right? It's the all this thing are that thing. It's the all A are B form, and that's what this part here says. All cats with pleasant dispositions are cute. But we don't have KX. We don't have that. And the domain isn't everything. The domain already is cats. So you don't have to add a predicate to say X is a cat. As soon as you say for all X, you're saying for all cats. All cats, so all you need to do is you can get rid of this bracket here. We're going to put a parenthesis here. All you have to say is for all X, meaning for all cats, any cat is such that if it has a pleasant disposition, then it's cute. This says all cats with pleasant dispositions are cute. Because the domain is cats, you don't have to add a predicate that says is a cat. We've already got that. Next one, some cats who do not sleep all day do not have a pleasant disposition. So there is at least one X such that X is a cat who does not sleep all day, and X does not have a pleasant disposition. You know there is at least one X such that because some means there is at least one. And when you say some cats, there is at least one X such that X is a cat, well, you've already got that because the domain is cats. So all you need to do right here is put in there exists an X. That means there is a cat. What about that cat? X does not sleep all day, and X does not have a pleasant disposition. And we know that X does not sleep all day is just not, is it SX? Let's go make sure that I got the right predicate symbol. No, S means smart. Sleeps all day is D. Okay. So X does not sleep all day. It's not the case that D applies to X. And is just the ampersand. X does not have a pleasant disposition. It's not the case that LX. I really should have had this, excuse me, this interpretation kind of right next to us. Let me do that here. Let me add another page, which I will just put next to this one here. So I'm going to have these next to each other. We'll have the interpretation here, and we'll have what we're symbolizing right next to it, so we can just look over there on the right. So, one more. Oh, two more. Good. So, there exists an X such that not DX and not LX. Some cat that does not sleep all day does not have a pleasant disposition. It's not true that all cats prowl at night. Let's see here. Here's how you say all cats prowl at night. There it is. All cats prowl at night. For all X, PX. That says all cats prowl at night. And all we want to say is it's not the case that all cats prowl at night. So negation of, and I'll just paste that, not all cats prowl at night. Right? It's just the opposite of what you had already symbolized. And then two more. Oh, okay, so I gave you an extra one. I gave you number 17 as well. I'll just mark that. So you don't have to do number 17. Number 18, it's not true that all smart cats have a pleasant disposition. It's not true that all smart cats have a pleasant disposition. Do we have all smart cats have a pleasant disposition? No. So we have to symbolize it. For all X, if X is smart, right, for all the cats X, if X is smart, then X has a pleasant disposition. So we will plunk in the symbol for all X. So it's not true that all smart cats have a pleasant disposition. So it's not true that, okay, that's just going to be the tilde that's going to go in front of that. It's not true that is just the tilde. And then we have to symbolize all smart cats have a pleasant disposition, and that's just for all X. Oops. If X is smart, then X has a pleasant disposition. There we go. It's not the case that if X is smart, then X has a pleasant disposition. It's not the case that all smart cats have a pleasant disposition. Notice that for 17 and 18, you can do something equivalent. Now, I haven't given you any rules of proof yet, but semantically, intuitively, I hope that you see that there's an equivalence here. It's not true that all cats prowl at night. That just means the same as, when you say not all cats prowl at night, that just means there is a cat, there is an X that doesn't prowl at night, right? Not for all X, PX means the same as there is an X not PX. So either one of these is the correct answer for number 17. And in fact, that works here, and then you could actually use other rules to show equivalences. Not for all X, if SX then LX. Not the case that all smart cats have pleasant disposition. That means the same as there is an X, there is a cat that doesn't have a pleasant disposition. There is an X such that SX and not LX. Which, if you want to see how that works, there's an intermediate step here, of course, which is for all X, not, and then this whole business was right there. Equals this. So what we've done is we've taken this negation, and when you pull it through the, let me see if I can make this work here. When you take the negation and you pull it through to the other side, when you sort of pull it through the quantifier changes from universal, in this case, to existential, and the negation winds up right there, right? And then you can think of, for this part, you can think of separating off just this part. This just has the form. If you think of propositional logic, it's just not, I can't draw very well with this touchpad, but it's if not, if P, then Q, right? It just has that shape. Even though the P is SX and the Q is LX, if you think of the negated conditional rule, right? Negated conditional just says that not if P then Q is equivalent to P and not Q, right? So we're going to get to some rules later that tells you, you can drag the negation through a quantifier from the left to the right or from the right to the left. You can go either way. The quantifier changes. And then you could even apply, propositional logic rules, statement logic rules. You could turn not if S then L to SX and not LX, like that. So let me get rid of some of this clutter here. and get rid of my pen, get rid of draw. And so I'm missing my quantifier here. That fell off somewhere in the process. That quantifier still goes out there. So when you say, and so this is, even if you don't see the, the step-by-step manipulations of the logical properties of the components, intuitively at least, it's not the case that all smart cats have pleasant dispositions. That means the same as at least one smart cat doesn't have a pleasant disposition. They mean the same thing. So intuitively, this is probably the most obvious right answer, and this is another intuitive answer, and they're both correct. Finally, no cat prowls at night unless it is cute. And then, however, all cats are cute. So we have the semicolon and the however, so there's going to be an ampersand and all cats are cute. We already know how to say all cats are cute. We did that somewhere already. Well, we did something like it. All cats prowl at night. It's going to be all cats, for all x, cx, right? So no cat prowls at night unless it is cute. No cat prowls at night unless it is cute. So you have to figure out, what does that mean? For all x, it means, you could think of it as saying, for all x, either x doesn't prowl at night. For all cats, either it doesn't prowl at night, or else it is cute. No cat prowls at night unless it is cute. Or another way of saying it is, only cute cats prowl at night. So there are different ways to look at this. And the way I'm looking at it with the for all cats, x, let's start with the universal quantifier. So we're going to say, for all, this is a trickier one, for all x, either, because that means, the unless means or, right? So no cat prowls at night unless it's cute. For all x, either it doesn't prowl at night, or else it is cute. Yep, got to get out of there. Or else it's cute. However, all cats are cute. And because the domain is cats, you don't have to add a special predicate symbol for it. For all x, cx. For all cats, they're cute. So for all x, either it doesn't prowl at night or it's cute. And this part right here, no cat prowls at night unless it's cute. It doesn't mean that all cute cats prowl at night. It means if a cat prowls at night, then it is cute. So another way you could have written this whole thing, I'm going to copy this over to the right, then I'm going to change something. You could also have written, for all x, if x prowls at night, I missed my x there, sorry about that, I don't mean to mystify and confuse you, there's supposed to be an x there. For all x, if px, then cx. All night prowling cats are cute. No cat prowls at night unless it's cute. Right? So if it prowls at night, it's got to be a cute cat, and anyway, all cats are cute. So that is the solutions, and what I'm going to do is I'm going to separately post these solutions, and then you can watch the video for how I got there. Or maybe you watched the video first and then you looked at the posted solutions. And your task is to do the rest of these, to work the rest of these problems and submit them by the due date, which I will post momentarily. Thanks very much for watching, and please email me or email Rebecca if you have any questions.